Hi everyone, this is Cloud Dragon Podcast, and today I'm going to talk about how to create cost-effective applications. You might ask, what do you mean by cost-effective applications? And I have a definition for you. I think that cost-effective application is one that can be built, written, tested and deployed in a really short period of times, like few weeks, a month, something like that. So you could just rewrite the whole application in a short period of time. And it sounds kind of crazy from the first look, but it actually makes a lot of sense for me based on my experience. First reason, because this is very important, it's about the time. When you develop an application, for example, you're a startup and you want to sell your software as a service, and you want to develop it first before you could sell it, and then you develop it, then you market it, or as usual, you do it simultaneously. So you hope that at a certain point of time, what you have invested in the project in terms of the salary, infrastructure, marketing, all the risks you had to take to account in, at some point of time, your investments, they pay off. That's your hope, but the reality is that if you have a project that is really kind of long and it's really big, it goes from year to year, the more you wait, the more unlikely you actually to get to this situation. The longer the project is going, the higher is the probability of failure of it, because the business changes, the world changes. Like in 3 years, your startup may be already out of time. Somebody else already built such application and you're just coming not in some new market, but already in a market full of competition. So the time really matters here. Priorities may change for, during that time. Investments could run off. People could get, key people may just leave the company for some reason. The longer the project is going, the higher the chance that it's going to fail, and the probabilities kind of goes up like crazy. So you want to finish the project as soon as possible, because that's the only way to actually finish it. If you're going to wait and you're going to plan everything and build a good architecture, and you try to spend time analyzing requirements and so on, you're just heading for a failure. So you want to minimize amount of all this of time solving problems that don't have to be solved right now. So you want to be agile. You want to solve right now what's important, and then when you get first revenues, you get first customers, they will tell you what they need. They will tell you what features they want. If the performance of your service is not good, if scalability is not good, if there is something wrong with the service, they will actually guide you. But what you want is just to get some customers going right from the start. And I'm not talking at this just from the business side. If you're a developer and you develop a certain feature in existing application, like imagine you have a company that you're already working in, it already have a product that gives revenues, and you think, how this is relevant to me. Well, each feature that you build within an existing product is kind of a product by itself. So I'm showing here example for a huge project but that equally applies to any small features that you have in existing product. Let's take an example of AWS. AWS is hundreds of different services, and each service is kind of a different project for AWS. And within each service, there are some key features that actually makes AWS more competitive than others. And these key features are the business changers, let's say. So it doesn't matter that you already have a business and you have an application going and you just need to support it. That's not how it works. Each feature, each improvement that you do you could think about this as a separate project that is supposed to increase your revenues or reduce operation costs, whatever. But the idea is that everything you do as a software developer has to pay off somehow, because if it doesn't, there is no point to do that. And it has to pay off as soon as possible. There is no point in doing something that will pay off in 5 years from now. For example, to build a super pooper high available application, if the closest outage due to the server failure is going to happen like in 10 years on average. Or it doesn't make sense to optimize your system if optimization will pay off only like 5 years from now, when you will actually get a lot of customers. Because over this time, a lot of things may change. So you probably want to create an application that is incredibly simple, that you could just write in a month or in a few weeks. And if you need to adapt it, you could just do it. So every feature, every small thing, every Jira you have, you want to reduce its time to market, time to production, where it actually makes gives benefits for the company. So this idea about short release cycles applies equally well for the features, for products, for applications, for business models, or for businesses per se. So it's just a different scale. But you want to release the key components as early as possible. And that's why the applications that don't release fast, they are not cost effective. And they are, sometimes the cost matters, and they may not even survive because they are not that cost effective. So if you do this iteratively, in 5 years, you might build 20 applications or features, and 2 of them could give you profits to actually going on. Like if you're just if you're not a business person, but you're a developer, 2 features that you have built over 5 years may actually lead to your salary raise, for example. But if you just work a lot of time on some very important things, but you just finish 2 projects in 5 years, maybe you will not get a raise for them because of the time it took to finish them. They may be incredibly huge, but you personally may not see the benefits. So it makes sense to do a lot of small things fast, and some of these things will pay off to you, rather than put your stakes on few really cool technologies or things that you will develop for a lot of time. So whatever you want to do, you have to do it fast. Another reason that I personally favor is that as a project goes on, you lose motivation to work on it. You lose your passion. When I have a new project and people come to me and say, "Oh, I want to build this one. I need this software to do this thing," I'm kind of motivated from this desire from other people to actually do something. Like when people ask me to, help them with something, initially I have an incredible desire to help, and I'm super motivated and efficient in doing so. But if I have a long going project that I'm in for 3 or 5 years, I'm not motivated to do anything about this project. I know everything. I know that you may not do, if somebody asks for something, I could say, "Oh, maybe I will just say that I will not do this, or I will just try to postpone this. Maybe they will change their opinion and I will have less work," something like that. So it's a totally different mindset. It's counterproductive mindset, I would say. So you want to work on some feature or on some problem just a few weeks or a month, before you lose your motivation, before it becomes a boring, non-passionate day-to-day work. Because I mean, I don't like boring projects. It's better to do boring. It's better to finish some project incorrectly or suboptimally in 4 weeks than to do it right in 3 weeks. In terms of the internal reward perspective, if I do some project in 2 weeks, oh great, cool, I finished that, let's improve it. But if it drags for 3 months, after 3 months, I don't feel any emotion because I'm tired with it and I'm just happy it's kind of finished. And then you have to support it, you have to improve it, and it's even more depressing. So it's actually beneficial for a developer to finish the work fast, because if you don't do it, you're gonna pay for it with your emotions and with your career development, let's say. And another reason why I choose the time component definition of cost-effective applications is because if it takes a lot of time to rewrite your application, nobody's going to do that. Like if you have a project that is so big that you cannot just rewrite it, you cannot control it, nobody going to do anything with that. Like it's going to stink. Like if you have a car that doesn't move, it's just going to be buried into the ground because nobody wants to pull it off the ground. And the longer this car is in this mud, the deeper it goes, the less desire there is for people to pull it off. So you want to make sure that every code, everything like in terms of the code perspective is mobile. Because as soon as it goes past a certain threshold, it's a positive feedback loop process where legacy becomes more legacy and more legacy and more legacy over time. It becomes worse, not better. And when it hits a point where you just can't rewrite the legacy in any period of time, like you cannot rewrite it in 3 years, it means that even a part of the code cannot be rewritten in a reasonable amount of time. So you lose control completely after a certain point of time. So you don't want to make your code a legacy because of that. And the way you make your code legacy is by making it in such a way that you cannot rewrite it in a reasonable amount of time, or at least rewrite parts of it in a reasonable amount of time. So you just have something that you just can't do anything about that. And for me, that's a definition of legacy code. Some projects, they are legacy right from the start because you can't do anything about them. You just have to rewrite them. So that's kind of a definition. But we have a definition of cost-effective application. Okay, let's assume that this is the correct definition, that in order to make application cost-effective for developer and for the business and for humanity in general, in order for app to be good for everyone in all circumstances, it has to be built, rewritten, tested, deployed in a short period of time. So that's my assumption, and based on that assumption, I'm just going to tell you how to do it. It's very similar to what I will talk about is going to be very similar to agile methodology, which nobody actually implemented it correctly because it's impossible, but we should strive towards it. Same goes here. You cannot really make a super cost-effective applications that cost zero to you. It's not possible. So what we are trying to do is to make it as cost-effective as possible, with a reasonable amount of efforts. So these are kind of a few very simple tricks that would cover like 80% of cost effectiveness, let's say. And after that, you could concentrate on other 20% because these are going to be your specific cases, how to make your app more cost effective, how to release faster, how to be agile with your code. One thing that you need to understand is that code, the application code, is just a teeny bit of the whole solution you give. Because the code is just a code. You have a database, you have customers, you have UI, you have load balancers, infrastructure, you have to manage it, you have to monitor it, you have logs, everything goes, the code is just a tiny bit in this system. Like if you have an engine in your car that actually does the transportation, the engine actually gives an energy to move your car from point A to point B, the actual ways you do it is, you need a whole infrastructure to actually move yourself from one place to another. And because of it, your code is kind of innocent. Like if you have a legacy, it's innocent. Like it's not a problem of the code per se. Like I've never saw a situation where everything around the code is great, but the code is bad. Like it never happens. The code is a kind of the last thing that connects all the bits and pieces. And if these bits and pieces are crap, well, the code that connects them is going to be crap. So the code itself is innocent, and you could rewrite and it's innocent because the assumption is that you could always rewrite it. You could just rewrite the code if you have a proper testing, if API is good, if documentation is there, if it covers all the use cases, if you have a good architecture and the database structure is okay, and infrastructure is not some weird stuff that nobody supports right now. If everything is more or less good, you could rewrite application code with no problem. Like you don't need to concentrate on the code itself. It's never a problem. So we're going to talk about everything but the code itself, because that's actually what contributes to the cost effectiveness of application. Because if you don't like the code, you fire a developer, find another one, he will write you a good code. That problem is easy to solve. You just find a competent software developer, he's going to solve this part. But this part is not easy to solve because it's a multi-dimensional thing. So first thing that I think this is the most important thing about applications that you develop is that they should be testable through the API. Like the testing pyramid that typically is told, and you could find it out in best practices testing, in my opinion is just completely wrong, because it doesn't take into account the cost of the whole system. If you account for the costs of the business, of developers, of the salary of everyone, and architecture and so on, you will find out that you just need to have a huge amount of API tests. Because API tests, they don't change when you refactor the code. They don't change if you rewrite your application in a different language. And they don't change if you change a UI a bit. You may add a new API, but the old APIs, because the clients use them already, old APIs are always backward compatible and they never change. Almost never change. So it makes sense to build your testing framework around the API and not around unit testing or testing components or testing everything as one system. You probably want to test each API, however it is, I would say, separated from other components separately. So if you have API number 1, you test it as a single thing. Even if it's not one service, if it's a microservices architecture, doesn't matter. when you have one API, you test it as a whole, and it actually, it actually creates a good system, a clear separation of responsibilities between services. So testers, they may see the API tests, and that's enough for me. How this system is constructed on the backend, it's not their business. Developers could construct, could create one service, 10 services behind the scenes, but the API defines the interface that should be tested. Everything else is really not important. You could use unit tests for testing some specific calculations or some specific complex logics that you could take off into some pure function that just have data in and data out. But for the rest of this stuff, the business applications, you want to have API tests because they kind of represent reality. And here is an example of such API tests. So these are just, it's a certain story that you describe in the test. So you want to cover a certain use case. So you go through this use case from the beginning till the end. For example, you create a transaction, then you see it's created, you try to create another one, you expect it to be failed, then you try to do something with transaction, you try to refund it, you try to refund it again. So so it's not like you write a code. It's like you don't prepare the test and then test a small bit. The whole preparation process is a test itself. So it's a whole use case that you should cover. So you say if you have to prepare a test in a certain way, it means it should be a separate use case for that. For example, if you have a customer that in some rare cases uses feature X, you have to show how this customer gets there. So it should be a part of this preparation step. It's a part of the test basically. And this test scenario, you make a request, API just handles it normally, and you don't want, depending on the amount of dependencies in your service. The database, okay, you could mock it. You could just, you can have a database in QA. If you're running tests locally, you could mock it in a Docker. But you should also have mocks for external APIs. So if you have, for example, a payment system, when you make a payment, you should simulate a few responses from this payment system, how it behaves in the different scenarios when you enter invalid CVV or your card has expired. So every external dependency that you have, kind of a separate service, if this service doesn't provide a testing API, a sandbox API, which you could just do whatever you want with, you should mock it because the tests depend on that. So if something changes in your external system, your test should be still kind of working normally. Most of the services you will use don't require mocks because they actually don't do anything. For example, if you have an external database, you don't need to mock it, you just use it. If you have some other service like, I don't know, S3, you don't need to test it because you just store files here. But if actions actually do something in an external world, for example, a credit card may be charged, or SMS or email may be sent to real customers or some real external systems, you want to mock it. But everything else, if functionality is okay to be tested, you don't need to mock it. You could just call it normally. So these API tests, as you see, they could work equally well in local environment and in QA, in dev environment. So it's very kind of it's very easy to see if something has failed right away. Like if you could run regression as a developer locally, QA doesn't need to run it at all. You could just run these API tests with mocks in a pipeline, on a local machine, wherever, and it's already a whole regression finished for you. You don't need to do it. It means you could just test your service manually. If it works, release to production. Unit tests would not achieve that because, well, unit test is just a small unit. It doesn't guarantee that API behaves the same way. Only these API tests can guarantee that. And these API tests, they are incredibly good. They are super because, first of all, this is a documentation how to use your service. You don't need to write Confluence pages, document, wiki pages, whatever. You already have a test that tells you how to make requests, which parameters should be here, what values you put in here, what responses you could expect and how to handle them and what they mean, and what is the flow of the calls in terms of the ordering. And you could add comments here to explain why you constructed test in a certain way, which already serves as documentation. So you just have everything in one place. You might not even need a Swagger if you have this API test, because Swagger is useful only just to, I don't know, to create a client in to use the API because you want to know which parameters are there. But the Swagger doesn't help you because it doesn't tell you how to use your API. But these tests, you just read them, you just copy the behavior, and your app works. You don't need to know that there are 150 other parameters here. You already know that you just need these ones. This is the minimal parameters you need to actually make what you want, and the rest of it, you don't care about that during integration phase. You could look it up in some more detailed documentation or in the source code or in a Swagger, but when you're integrating with API, you just want the simplest stuff outlined here. And ideally, you should have everything here, all the use cases, all the parameters tested here, because it makes sense to cover as much things as possible with your API tests. And it's also good because you could compound multiple flows together. So instead of testing all the failure modes of this API and all of the failure modes of this API and this API, you could make a long test that does all the, which covers all the use cases at the same time. So you create transaction, then you try to refund it, you try to refund it again, then you try to deposit refunded transactions, that you try to repeat a refunded transaction or a canceled transaction, or you try to cancel a refunded transaction. So you could just write a lot of statements right here. So you make one valid step, and then you could make like 10 invalid steps after that. And then you again make one valid step, and then you can make 10 invalid steps later to test for, do the negative testing. But the point is that you just have one testing flow. You could just read it. Or you do this one, this is not allowed. Then only this operation is allowed. Then all these operations again are not allowed. So it again serves as documentation what you could do with the API and what you shouldn't do with the API. And in order to make your API testable like that, it has to be designed in a certain way. So for example, you want to trigger some test scenarios. The API should support that. So if you send a certain magic number, well, then external system, for example, this mock returns another response, and it's handled differently. So your API should allow simulating a certain failure mode, so you could test what happens if the database fails, if external system fails. So the QA could actually write tests that make sure, for example, that concurrent requests are handled properly, or that for example, if something has failed on external system in its database, the record, for example, is handled correctly on external service. And it's also a good thing, because if you know that you need to make your API testable in such a way, you will find out that if you have 10 dependencies, you have to write these mocks and failure modes for each of these for each this dependency. And it kind of internally motivates you to not have these dependencies at all, to just have a database and a code and the minimal things you actually need from external system. If you need a queue, you might think, oh, I have to test this queue. What if queuing fails? I would better just write this record into the database, and the whole testing scenarios, they just vanish because you don't have a dependency. You don't have to test it, how it behaves and how it works. So it makes everything so much simpler. It's just crazy. And the whole reason of all these API tests is that if you have them, you could rewrite your application like in a few weeks. You could refactor it. You can rewrite your app in a different language, and if it's still going to pass API tests, you don't care. You don't care if architecture changes, if it's different framework, or you deleted all your unit tests because you're moving to another internal code architecture. Doesn't matter, because the API is always the same. Internally, you could update, refactor, change anything you want on any scale you want. You could rewrite whole application. You have API tests that will tell you if the app behavior is backward compatible or not. You could migrate NoSQL to SQL. You could do whatever you want, and still your app is testable, and it's going to deliver the same feature set that it was delivering previously. In contrast, if you cover this with unit tests, as soon as you change your architecture, you have to rewrite everything. All the unit tests, all the integration tests, you have to rewrite them because everything has changed. But if you have testing through the API, well, you just need to rewrite the code because external dependencies, you already wrote mocks for that. You have databases. The testing is the same, so you just rewrite an API logic and it just works the same. With the tests, it's pretty simple because you could have API tests, and if you have API tests, you could rewrite application pretty fast. You could modify it. It can be agile. But with the databases, it's an opposite of that. The database schema has to be designed correctly right from the start. If you choose the wrong database, or you choose a wrong schema for your database, or you store the data in a wrong format in the database, it can screw up everything. Because, okay, you could rewrite application, but if your data is stored incorrectly, you're doomed. Imagine you have, the database is kind of a library. If you have books that are ordered in a certain way, and you have a certain departments in libraries, you have rooms. This room is for scripts. This room is for books. This room is for maps, let's say. If you have it properly organized, then rewriting the behavior of people who are actually going and doing something with this library is not going to be a problem. In fact, businesses in the past worked with just paper, and they worked in a similar way. They had a database of these books, of papers, of all these logs and records, and they work just fine. We're just replicating that. So if we store this data in the database, or in the databases incorrectly, it's going to spoil everything. If I have a poem that is split, if the first part of the poem is one room and the second part of the poem is in another room, and the third part of the poem is in another library, well, I have trouble reading the poem. The same goes here for the databases. If, it doesn't matter if you change your behavior in terms of the managing of the data, if the data is incorrectly stored, it doesn't help. So you have to store the data correctly right from the start. Or if you store it incorrectly, you should adjust this as soon as possible, because the data accumulates over time. And if you think that, it's true only about SQL, because in SQL you have to think about the schema, how you're going to store it, you have to go through all these normal forms. It's not. The exercise that is done during SQL schema definition is the same exercise you should do with NoSQL, because NoSQL doesn't really solve any of the problems. It kind of makes it simple to start working with applications. It makes it simple to do something. For example, release your MVP in 2 weeks and 3 weeks, so to do something first. But then it doesn't really give you the guarantees that the data is stored correctly. So you may think that, I will just create an object, I will put it into database and everything is fine. But in fact, you might just didn't think good enough about this. Maybe you should take all the information about the customer, put it into one too big object, and that would be the correct schema. But because you just thought that NoSQL handles that automatically, well, you just design something wrong on NoSQL, because it doesn't matter if you use NoSQL or SQL, you could still make design mistakes. Same goes for scalability. You think NoSQL is scalable. It may not. If you designed it incorrectly, it may not be scalable. Same goes for transactions. You think, I have NoSQL, I don't have transactions, I don't have to worry about transactions or transactions performance. Well, again, if you designed your NoSQL incorrectly, you may try to update one record 10,000 times per second, and it's just not going to work. And NoSQL is very easy to start writing your application, but you could actually screw up a lot of stuff right from the start. Because as I say, the database, the code, you could change it all the time, but the database, it's kind of, if you created one database, it's much harder to update it to another one. You actually have to rewrite the whole code to do that, but you could actually rewrite the code without changing the database. So the database is 80% of success, and you should not just use an NoSQL just because it's easy to start. You have to go through the painful process of database design before you start doing something. It's counterintuitive to what I've already said about delivering applications fast, because it makes sense to deliver results pretty fast and not think about the data too much. But actually you have to invest this time, some of the time, into the database design, because this is what's going to pay off you in near future. And the way you do that, well, I usually do it in 3 steps. The first step is, as I identify which entities do I have in the application, what business entities I have. Not the entities that make sense from the, let's say, from the developer's perspective or the technical perspective, but the actual words business people use to describe the application. when they build a UI, and that's actually also a very important part here, that your backend depends on how the designer actually created this UI. If UI is wrong, your application may also be wrong too. Anyway, so on this UI you have words, and when the business tells you what they want to implement, they also tell you this with their words, the business words they use. And you should take these words and just use them as business entities. So you have some payment, you have a shop and you have a wallet, you have payment, you have orders, you have cards, you have offers, you have services, accounts, users. So all these words are coming from the business. I didn't invent them. When we identified all the business entities that are going to exist in our application, we need to define which entities are closely related to each other, not in terms of logical relation, but in terms of updates, like which entities have to be updated at the same time atomically. Let's say this is some shopping platform, and the amount of money in my wallet and order and payment, they're all connected to each other. So when I create an order, a payment is made and the wallet amount is deducted. These all are, in one thing, let's say. Yeah, I may try to separate the payment somehow, try to do it like this, but then I just I just shifted responsibility for managing the payments to this service or to this service. So it really doesn't help that much. So if you have multiple entities that are updated at the same time, they are really closely bound together, they should be kind of one service. So you need to find out what just imagine how you would write the code and what transactions you would have in your application. And if SQL transaction, let's say, updates 3 items at the same time, well, it means all those services, all those entities should be in one service. And one service doesn't always map to one entity. So if you have an ordering service, it may have an order, it may have even wallet, and it may have payment. It maybe doesn't make sense to design like this from technical perspective. You may want to put wallet aside as a separate service, but this the requirement that you need to update all of these 3 values at the same time kind of gives you a hint that you need these 3 entities in one service. And even if they are not related to each other, you could group them together. For example, you have some service that manages configuration. You just add a lot of configuration entities here. Or the user could have a profile, account, card. I mean, it's all related to user. You could just move all those entities into one service. But in fact, you could move it here to a microservice if you want. You could build it within one big service. It doesn't matter, because it's really not a problem, because you have a correct design that everything is separate from each other. But if you will have a connection like this, then you have a problem, because now your update have to span multiple services, and you have to invent Saga or two-phase commit or other distributed transaction techniques. So it's going to make everything painful and interconnected. So you want all your write operations for multiple interconnected entities to be in one service. And the last step in the design is to choose the proper partitioning scheme. So if you have like 5 services here in your software as a service solution, like imagine we have some website like Shopify that have that you could create your own shop, and you have a user, you have wallets, you have profiles, etc. But how to ensure that if I have like if my customers, if I have a lot of customers and their needs grow, how do I make sure that I could actually support this operation? How do I make sure that I could sustain the performance requirements or the data storage requirements? How to make things simpler for me in terms of the managing all of this. And if I would be, let's say this is a shop platform, some that I just provide, I would probably want to cluster it by something that is guaranteed not to exceed a certain throughput or a certain size of the data. So for example, if I cluster this by user, well, the user might have thousands of different shops. It may be a big customer. And if I cluster the database by user, well, his 1,000 shops may overflow my one server capacity, and I can't provide anything. However, if I will say that I want to cluster my system by single shop, then it makes sense, because in one shop, well, you may have 1,000 customers who are buying things in parallel, but you can't really have more than that, because it just, if you have 1,000 purchases per second, you're gonna be like Amazon. So you will probably never hit a situation where you have so much customers per single shop. So you could just take this shop and use it as a partition, and everything that happens in the shop, it's kind of consistent. Because if you have a shop and you want to update some data, for example, you have a transactions that spans between orders, payments, and wallets, as I showed previously. Well, it always happens in a single shop. It always happens in single partition, which means you don't have a problem that you have a transaction spanning multiple partitions. It means even if you use SQL, you could put one shop on one database and another shop on another database, and it's still going to work because all the transactions, all the dependencies are managed within a single shop. So that's the whole point of partitioning, is to have a certain bits of data that you could have on a multiple servers, and they just work perfectly. They have all the consistency required, and they all have the performance required. So for example, if you see that the number of shops for one customer grows, well, you move some of the shops to another server or to a separate server for this customer, and everything works just fine. But if you would separate this, if you would cluster this by user, well, you might face a problem because one user could have a lot of shops. Now you know that you have to, one server has to sustain performance from potential user who has hundreds of thousands of different shops, and each shop could have 10 or 100 parallel users, and you will soon find out that one partition could potentially handle a lot of requests. And then design of the whole system becomes incredibly complex because you have to ensure this performance requirement. But if you're just partition this by something that guaranteed to have a certain limits on the amount of data stored and amount of throughput coming into the system, you could make your life much more easier, because now you don't need to think about performance of the whole system. You can think about performance only from about performance of one partition. And then you just scale partitions as you want. Here is another example with task management system like Jira. If I scale Jira by project, I could create, I could put the whole data of the project into SQL or one big JSON object, and I just manage it. I know that for one project, there will be, maximum 1,000 users. Nobody is going to have a project with 10, even nobody is going to have a project with 1,000 of users, because it's counterproductive. You want to, separate teams into small clusters and so on. So the reality itself tells us that we should cluster by some things. Businesses typically already do this clustering. For example, if you have a pizza venue or pizza company like Dodo Pizza, they don't sell everything from one city and one building. They have multiple offices, and each venue covers its own area, and it has its own database. And if internet goes down, well, they could still manage it somehow locally, for example. So they separate their business by small parts. Even if you have trouble with one project, well, others are not affected, for example. And the last benefit of this is that when you make a correct partitioning decision, all the testing happens per partition. Like the performance testing happens per partition, and the regression testing happens per this partition. So for example, if you have a shopping platform, you could create a new shop, do whatever testing you want, and then delete it. Or you have a project management system, and you want to test how project works. You create a project, you run a load test, you delete a project. So it's really cool way to make your testing kind of match the scalability of the business, because otherwise, I can have a customer with 1,000 shops, and each shop has 100 users. Then I have to have a load test for like 100,000 simultaneous users. Now, how are you going to conduct that? That's not realistic. It's wrong. So what you do is you just partition your service by small parts, and then you just have to test and manage just small parts. And the way it scales in productions, you don't care about that, because you know that each part is independent. So you don't have to, you don't have to make a production level load tests here. You just test the load equal to the biggest load on the partition you have in production. So it makes everything much more easier and simpler. And the database, it's actually only one of the dependencies you have. So it's very important to make the database decision right, because ideally you don't want to have any other dependencies in your app. If you have an option, if you don't really need an external service for the functioning of your application, you probably want to just use your database for that. For example, you think, I need to store files that users upload per project, and I want, these are files, so I have to store them on S3. Well, you don't have to. You could store them in the database, even though the database is not a good storage for the files. You reduce one dependency that you have to mock, test, maintain, and so on. And if the database works just fine, with additional costs for storing this and performance, well, it just works. Yes, it works slower, or you pay more for the storage, but it may not be a problem for you. It may, maybe you have a database and it has a special table for files which is stored on some cheap storage, HDD, and you just work with that. So your app has just one dependency, and you could test a file upload and so on without having to be involved with S3, for example. Same goes for caching. If you don't need a caching, database may just cache requests equally well. Unless you actually see that you need to cache something, then you could introduce some centralized caching solution. And it goes for every dependency you have. For example, queues are a good example. People often try to use queues for everything. Well, you might just put the record into your database and just have a process to take a record from the database and process it. Same queue works equally well, especially with SQL databases. And that's it. You just have a queue. If you don't need million requests per second, you might just live equally well with a database solution. So if you try to minimize all your dependency, your application becomes much more simple, which means if you need to change something, for example, I need to change the way the queuing works, I don't need to spend hours configuring, setting up, getting access to AWS, to configure the SQS, to find out how it works under the hood, to learn the documentation. I don't need to do that. I just go into the application and see, oh, this is how queuing works here. I could just update it. So every dependency really slows you down when you doing this release cycles or initial product development. Each dependency, is a problem for you, and you want to get rid of it. Even if your solution is not optimal with just a database, as long as it is on acceptable level, it's fine. And you could just save a lot of costs just by, you may lose, for example, you may have to run a bigger database, for example, and pay for it, but the costs that you save on your time, on the salary of developers, etc., are going to be much higher. So you could save more on the people's time rather than on some database performance or database size. And you also, if you do it on the database level, you could always move it to, you could always take it out from the database and put it onto external service. For example, files on S3, if you store them in the database, you see you have a lot of files, you want to optimize this. Okay, it's important for the business, it costs a lot, let's move them out. And so you add dependency, not just because you want to add it, but because there are real reasons behind that, because you really need to do that. Otherwise, you just have an incredible AWS costs, for example, or you have problems with database performance. But before you have those problems, you don't need to do that, because those problems may be imaginary. You may think that, people are going to update files and it's going to slow down the database, but maybe people who created this database already managed all the use cases like that, and they made the database work just fine with this use case. And when you have so much dependencies, they limit your agility in terms of infrastructure. Like if you have Cognita, SQS, SNS, and Lambda, and all other bunch of AWS services bundled together in your application, you don't have a cost-saving option. You could buy savings plans. That's it. You could ask AWS for some savings due to the commitment, but that's it. You can't change your infrastructure. You can't migrate to Google Cloud. You can't migrate to some cheap VPS server if you need to. You can't, because you use all of these dependencies that are specific to the cloud. Now you're just sold yourself to the vendor. And those clouds like AWS, Google Cloud, Azure, they're incredibly expensive. So If you see that in future your business is going to grow considerably, yeah, you might want to move. You might want to move some of the heavy processing out of those clouds in future, or I mean even migration of, let's say, of AWS to Azure or to GCP. If you have just applications that in the database, you could migrate wherever you want to save costs. But if you have incredibly complex solution, the only option for you is just to pay more money to AWS. So you don't have a leverage to negotiate about the pricing, even because they see, oh, you're using 15 different services on AWS. No, we are not going, we don't believe that you could move out from AWS. We are not going to give you a discount. But if AWS sees, oh, you have just EC2 and RDS used, of course you could migrate out. They would probably, you could negotiate for a discount or something like that, because they clearly see you could just migrate out with no problem. And of course, if you have application with minimum dependencies and good architecture, all the cost-saving options are available to you. Like if you really have a lot of customers and you have a lot of load on your servers, then you could think how you could optimize the costs for infrastructure. And if your app is simple, it's very simple to do. But optimizing beforehand just doesn't make sense, because it makes solution complex, and complexity introduces exponential costs to it. So you actually make your app more costlier by optimizing it for cost, which is kind of paradoxically. One last point I want to mention is that if we are talking about costs for developing applications and minimizing the release cycles, that you want to be able to create something fast or change something fast. It's not possible to do that if the change has to span multiple teams to achieve that. Like if you want to release something and release requires communication between 4 different teams, like in this example, you can't release in 2 weeks, for example, because you have to tell another team, they have to do something, they have to update the database with a new schema, they have to plan it, they have to schedule time for that, and so on and so on. So it's very problematic to have such a situation. So you want to make sure that your application release or product release happens within one single team, because when it happens within one single team, it's like a database and a transaction example that I've just explained previously. Once your change spans multiple teams, it's going to be like 10 times slower. But if you could do an update within a single team, and single team is responsible for one product, well, you could change this product within 2 weeks. You could rewrite it, you could change APIs, you could change UI. Because, for example, if here team X changes API, now all this front-end team has to adapt and change something else. But here it's the same team. They all have a daily stand-up, they talk with each other, they have much better communication with each other, so they could just plan all change in one sprint. Okay, you will do the infrastructure, I will do the backend, this is going to be an API, and one person going to handle Android, another one going to handle iOS. Boom, the change is done, because it's one team. There is a communication, everyday communication going within one team on a daily stand-ups, etc. But with multiple teams, you don't have daily stand-ups with multiple teams. They don't know what they're working on. So it's the things that I've described in terms of correct design of application and correct everything. It's not just a code design. It's API tests, all the stuff around the code, database, and even construction of the teams themselves, like how the team is constructed. If the teams are constructed like this, they could work with Agile, they could have Scrum, but well, you're not going to get the cost effectiveness out of this process. And one important thing about the teams like DevOps, DBA, people who are, they meant to be kind of a centralized, like, oh, we can't have a DBA person for every team, like it's overhead. So you have like 10 teams and you have like 2 database administrators, and you think, oh, then they're going to be responsible for the databases, and these people are going to be responsible for the application. No, this is not correct. The teams should be responsible for everything, and they should know how the database works, on which servers it runs, where to see the monitoring, what to do in case of the failover, etc., etc. So imagine you don't have DBAs, but you just bought a managed server, a managed service for the database management. For example, AWS RDS. RDS doesn't, it's not involved in your application development. It gives you the tools to control your database, but it's not involved in your database schemas or anything else like that. So the same should happen with DBAs. It's a service that they provide to developers, but developers and the whole team is ultimately responsible for everything. From UI till database, they are it's one single unit of responsibility, let's put that way. Same goes for DevOps. DevOps could provide Kubernetes cluster, they could provide tools to manage infrastructure, to create it, but they shouldn't tell teams how the infrastructure should look, how they should construct it, and what APIs should they have, or what technologies should they use. They provide a service, but teams are ultimately responsible for everything. And if that's the case, then application development goes fast and it's cost effective and it works fine. If not, well, it's not going to be a problem, but it's just going to be slower. And if you combine multiple pieces of it, like if you have bad architecture, if you have a lot of dependencies, if you have teams constructed in a weird manner, if you sum it all up, it kind of multiplies, and instead of projects that takes 1 month, you have a project that takes 2 years or 1 year. And well, if it takes too long, well, something's going to change and the project is not going to be successful. So wrapping it up, if you want your application to be cost effective from the business point of view, in terms of the return of money per dollar on your application development, you want to make sure that you have API tests. You have as much API tests as possible, because they actually make everything much more simpler from software developer perspective. You could fire developers with no problem, because if you want to change one developer for another, you could do that if you have API tests. If you don't have API tests, you can't do that, because all the knowledge is in this person's head, and you start to be dependent on this person. You have to have a correct database design, because you may change the person, you may change your developers, but you can't change your data. It's there on a server. You can't just magically transform it, because everything related to database migration is painful, it's long, and it's time consuming, and it requires a lot of efforts. It's actually prone to failure, because you may lose some data may be inconsistent, and so on. So it's really a problem. So you have to invest a lot of time and effort into the correct database design. Infrastructure, don't care about this. Just don't worry about infrastructure at all. Reduce the amount of dependencies, make it as simple as possible. You could just run the whole application on one server, no load balancer at all. It's still gonna work. It can still work while you would have outages, of course, but hey, it still works. You just restart the server, or you make releases at night where nobody's using your service, or you might have just some other architecture, but it has to be simple. You don't want to put a Kubernetes cluster managed by a lot of people or managed by some cloud, and then you run a lot of stuff on that, and you have a lot of sorry, got distracted. So you want to make it as simple as possible, and don't worry about CPU cycles, performance at all, because you could always fix that part of a problem if your application is simple. If it's not, you can't fix it. It's done. Even if you have incredibly efficient application written in C, it's not helpful because you can't do anything with it. And it may be cheap in terms of the infrastructure, but in terms of overall business, it's going to cost a lot. And of course, the last thing is that you have to construct the teams correctly to make these things going. If you have teams that, if you have products that span multiple teams, they will be, all development is going to be slow by definition, because it's a different kind of, you could think as them as different databases, a distributed system, and everything is in distributed system is going to be slow. It's much more effective to just take one product, assign one team to it, and one team would handle everything, starting from API, UI, finishing with database and how it's stored and security and so on. So it's very important. I saw this in many companies. If you span development of the products through multiple teams, it's going to be a problem. And if you have a product that is really big and you just have to divide teams, you really have to divide teams somehow because it becomes too big, you might think twice before doing the division, because you might want to create a sub-product and say that, oh, this team is going to manage this UI page, let's say, or this part, this feature set, or this thing. So you want, if you have to divide the team into multiple teams, you definitely don't want to divide it horizontally based on skill set. You want to divide this on the area of responsibility, on the features, on the services, APIs, whatever, but definitely never divide teams by skill set, like front end or back end or whatever. It makes sense a lot, because you think, oh, people on the front end, they want to talk with front end guys, and people on the back end want to talk with back end guys. My experience is that that's not what happens. My experience is that people who are, one team, and every team member has its good, strong and weak sides, is much more effective than you have a team of front-end developers and they just do the front-end and they talk about the front-end all the time. I see such teams are less effective than if you take each individual person and put him into the team. Because when a person sees that he's better at something than other people, and that the success of the product depends on him, and he will try to, he will have a meaning why he's working at all. Because if you work in a team where everyone is the same as you kind of don't feel that you are actually making an impact. But if you work on a product in a team and team responsible for everything, and you use your best qualities to work in that team, then it's just going crazy. Your performance is just going to skyrocket. That's all I wanted to talk about that. Thank you so much that you finished till the end of this long presentation. Hope it was useful and interesting for you. See you in the future episodes. Bye.